Here in example number 3, just a few facts again. I'm going to fill out my blank notes here. I'm going to put this side is x, this side is x, and the hypotenuse, which is across from the right angle, is x square root of 2. Right? So these two legs of the triangle that touch the right angle are both equal to each other, and the hypotenuse is the leg value times the square root of 2. So we're going to use this to go ahead and figure out our missing values. And notice in this case we're actually missing both legs, leg A and leg B. And they give us a single radical as our hypotenuse. And I know that's the hypotenuse because if I draw an arrow from my right angle corner, it points towards it. So that's C. Now, knowing that information, I'm going to go ahead and we're going to start working this out. So first of all, I'm going to go ahead and just label this as C, right? We know it's equal to this x square root of 2. And we're going to use that idea to solve for x. Because notice we do have an x in this statement. So what I'm going to do is I'm going to rewrite this as x square root of 2 is simply equal to my value for c. And my value for c is right here, square root of 3. So notice I just substituted the square root of 3 for c. Now you may be looking at this going, Mr. H, this doesn't seem to help me much. Well, it will, because now we can go ahead and use inverse operations to move this square root of 2 over to this value that c was equal to and to isolate x. So that way we'll know what x is equal to. In other words, remember that, and I'm going to rewrite it down here just a little bit to have a little bit more space. We have the square root of 3 is equal to x times the square root of 2. Remember that there is multiplication going on in between this variable and this square root of 2. So the opposite of multiplying x by square root of 2 would be dividing x by square root of 2. And if we divide the right side of the equation, we have to divide the left side of the equation. Now we know any number or radical, for that matter, can only go into itself one time. So square root of 2 divided by square root of 2 is just simply 1. So we like to say these cancel out on the right. And I'm simply left with x is equal to the square root of 3 over the square root of 2. Now, why again you might be tempted to stop right here, we can't stop right here. There is one extra step that we have to do from this point. So what we're going to do, because our problem is that we have a radical in the denominator. So what we're going to do is we're going to rationalize. We call it rationalizing the denominator. I'm going to move this up just a little bit so we have some space. Now I am going to rewrite this just ever so slightly different. Imagine I'm just picking it up with a spatula and flipping it over like a pancake. I'm going to put my x on the left side, equal over here, and the square root of 3 over 2, I'm just going to put it on the right. So square root of 3 over the square root of 2. And I'm going to rationalize the denominator to get rid of this radical in the denominator, because we don't want a radical in the denominator. The way that you do that is you simply multiply it by the denominator. That's a radical. So I'm going to go ahead and put square root of 2, and I'm also going to multiply the numerator by the square root of 2, because we want to go ahead and we want to make sure that we're keeping this balanced. So right, if we multiply the denominator by square root of 2, we got to also multiply the numerator by square root of 2. And if I go ahead and I multiply that out, for instance, I have square root of 3 times the square root of 2. That's going to give me the square root of 6 in my numerator. And then if I multiply the square root of 2 times the square root of 2, well, there's a rule that says anytime you multiply a radical to itself, it just becomes the radicand. In other words, the number that's inside of the radical. So square root of 2 times square root of 2 simply gives me 2. And so now I have what we called rationalized the denominator and simplified this answer. So my final answer is x is equal to the square root of 6 over 2. Therefore, b is equal to the square root of 6 over 2. And a that we're looking for is also equal to the square root of 6 over 2. And now we've answered our question completely.